So I'll be talking about the next generation of LLM and how we've designed a system that's very different from everything that's available, in the sense that it does not use transformers or deep neural networks. So it will be kind of a general presentation of the system, because there are many components that could be integrated also with traditional LLMs. A quick introduction about myself. I earned a PhD in computational statistics in Belgium, moved to a postdoc at the University of Cambridge, also in computational statistics. And I worked for a number of companies in the internet, finance with Visa, Wells Fargo, eBay, CNET, publishers like NBC, a number of startups and medium-sized companies. By 2008, I started Data Science Central, which is a platform for big data practitioners, it was acquired by TechTarget in 2020. Then when I sold, I resumed my research in AI, machine learning, starting initially with synthetic data, and then moved on to LLM. So one of the reasons I was interested in LLMs, I was doing research for myself. I needed references or asking questions to find references, essentially. And it played with Perplexity, OpenAI, Google, and the responses I was getting were pretty basic, or required a lot of prompt. It's called prompt engineering. And even then, answers from OpenAI that fetches content from multiple sources would generally be a mixture of something that's correct with something that's not correct. So not truly, I would not call it an hallucination, but essentially a mixture of correct and wrong answers. So eventually I decided to create my own applications. And I started with a large mathematical corpus, which is the Wolfram corpus, which is about 15,000 web pages. It's a very good corpus in mathematics, 5,000 categories and subcategories and so forth. And obtained results that were much more valuable to me, as particularly references and more advanced answers. I then was contacted by some folks, a company in Brazil, AB InBev, to develop a similar system. And what I noticed was that the enterprise corpuses were very similar, well structured. It came with also a taxonomy of breadcrumbs, a number of contextual elements that could be retrieved from the corpus, as opposed to create a knowledge graph from scratch. And so I created a system with a user interface that's very different from a prompt box, in the sense that the output is structured output broken down by categories with a bullet list for each category. Like, for instance, links, related keywords, the information that was displayed to the user was structured. So very different from long text, what I called prose. Although in the end, I added a layer to which this one uses deep neural networks to turn the structured output into long text, because that's what many people are interested in, even though it's much slower to get an answer that way, and it's subject also to potential hallucinations. One quick comment before moving to the actual presentation. One of the important things here is that it was not based on deep neural networks, so it's much faster. It can be done without GPU. The corpuses that I've been working with recently, mainly they are enterprise corpuses. They are much smaller, so you don't need the whole internet, so you don't need billions or trillions of tokens. Typically, you have much fewer tokens, like less than a million. And tokens I use are also different. They're multi-tokens. They're made of multiple words. And also the background. Like I said, I started with synthetic data, playing with deep neural networks, GANs, so generative adversarial networks, and to make them work, I had to add a lot of components, transforms, inverse transforms, normalization, standardization, so that it would work on as many data sets as possible. And at that point, I was wondering who's doing the job. Is it the deep neural network, or is it all the components that I added? Eventually, I did it without deep neural networks. It went much faster. I got better results. And the same applies to xLLM. That's the name I used for the LLM system that I developed. So let's move on to the slides. By the way, there are many slides here. I don't have the time to go through all of them, so I will skip big sections, but it's going to be very useful for you guys to have the full PowerPoint document that functions. There are diagrams. I won't have the time to go through it, but I will focus on the main topics and the main innovation here. Let me move to the next slide. So in this presentation, I will start with why xLLM. What is it? I've already talked a lot about it. I will go into more details. So the innovative features, the architecture and the evaluation. So that's a part that I will mostly skip. And the part number 4, xLLM for clustering, data synthesization. So I will briefly mention synthesization. Actually, that's one of the agents with a number of different, I call action agents. Look, for instance, you can retrieve tables from PDFs and then, or from the web or from a database, blend them together and make predictions based on these tables. That would be an agent called predictive analytics. So synthetic data is another agent. We're not reinventing the wheel. We are not building tons of agents. With a few agents, text clustering is another one that we will have experience with. We're not generating code, for instance, SQL or Python. If that's some customers would want to do that, we would use some external APIs. But typically, the client that we're working with, they want a highly secure solution. They don't want external APIs. We focus essentially on agents that are relevant to the business. Next slide. So let me dig a little bit into the main components of LLM. If you've read some articles that I posted recently and have questions, like I say, there's no hallucination. I'm going to explain a little bit how. There's little prompt engineering thanks to the user interface. I will also go through some of the details of that. But essentially, it's a mixture of experts. So a little bit like a DeepSeek, when they became very popular, I think one of the key points was a mixture of experts. Even for the first use of the word mixture of experts is probably at least 1 year old. And if I remember correctly, it came from Meta, actually. So what it is, you have a corporate corpuses with different parts, HR, marketing, sales, finance, and so forth. And for each of them, you have a sub-LLM that focuses just on that particular part. You also have authorized users, so not everybody can access every sub-LLM, and even some chunks that you retrieved you can assign authorized users. So it increases the security. It's something that the enterprise are looking for. No neural network. So if I use the word parameters in my conversation here, there are a number of top-level parameters, intuitive parameters, so it's not a black box neural networks. When I use the word parameters, it's nothing to do with neural network parameters, like trillions or billions of parameters, which essentially are weight in a deep neural network. Here, by parameters, it's more like the traditional signification of the word parameters, a few dozen parameters, back-end and front-end parameters. Concise results. I'll show you, because I've said that OpenAI and all other LLMs, essentially they show long text embedded into chat conversations. What we show to the user is very different. It's more like a concise, structured output. Even though we are also building another layer on top of it so that we can offer long text for the users who want it, and pretty much everybody wants long text anyway, so it's going to be something important for us. I probably won't have the time to go through case studies. Like I said, initially I started with the Wolfram corpus. I worked on a sub-LLM for a beer company, actually a Fortune 100 company, AB InBev. We working on a PDF repository, a public PDF repository, which are Nvidia financial reports, public reports. So we're working with different kind of data, like the corporate AB InBev came from databases. Wolfram, it's the internet, and Nvidia is a repository of PDF. You can have multiple different sources, blend them together, so that the first part of xLLM is extracting this information and turning it into a format that essentially something like JSON that then you feed into the xLLM engine. So yeah, this is the how the output look like. Actually, this is the user interface where you can enter a query, and the results that you're going to get consist of a number of, we call it cards. They comes from the chunks. So the summary information, like you see business metadata template, that's one of these cards. It comes with a title, it comes with tags, it can come with categories, can come with timestamp. These are contextual elements that are either retrieved from the corpus. The name of these fields can depend on the corpus, and some of them we add them post crawling, like tags or categories. If there's not a strong taxonomy, a strong structure associated with the corpus, we're going to add some of our own, and they're going to show in these cards. So we have like 10 cards for a specific prompt featuring chunks coming from the corpus, and when you click on one of those cards, you get the detailed information that you're looking for. If you were to work with a long text format, you need an extra layer that would look at all these cards, the content of those cards, and create text out of it to display a typical long text answer. Also, one important feature, it doesn't show here, but these cards come with a relevancy score telling you how relevant this specific card is to your prompt. This is pretty important in the sense that if you are looking for something that's irrelevant to the corpus, say the corpus is a corporate corpus, you're asking questions about philosophy or stuff like that, chances are that xLLM will return almost nothing, and maybe even nothing. And if it returns something, it's probably going to be barely relevant to what the user is interested in. So there's going to be a relevance score ranging from 0 to 10. Maybe we'll get a score of 1 telling the user that xLLM knows that this is not a great answer, that it's not very relevant to your prompt. We're aware of that. That's all that we could find in the corpus. And so we do that rather than providing making up an answer, essentially. So we don't do that. That's one of the part that there are many components that reduce the hallucinations, and that's one of them. In addition to these cards, Before I mentioned that, on the left side, you see that there are parameters that you can fine tune actually in real time to change the way the answer. So it's going to be changing some parameters in the algorithm, like the stemming, the distillation. We use distillation. I don't have the time to go through that. It's different from deep neural network distillation, but we do some distillation of our own. We use a PMI, pointwise mutual information metric, for embeddings and to find correlation between keywords. So it's different from cosine similarity or dot product or stuff like that. We don't use standard embeddings. They're variable length embedding, and we don't use vector database. The database architecture is native Python, at least in the base version of xLLM. It's nested hashes, which look kind of similar to JSON. And that makes it extremely fast. Actually, it's possible to do it because these corpuses are small enough, and we're not having billions of tokens, so it could fit in memory. So there's a version of the base version of xLLM is actually a in-memory xLLM with real-time fine-tuning. The other part in the answer, I believe it's in the next slide. In this slide, on the left, when you click on the card, you see all the details with the various fields, the text you're looking for. So that shows on the left, and on the right, on the user interface, it's actually better than what you think now. But in the most recent version, what you're going to see is relevant prompts or relevant keywords that you can with one click, essentially generate the next prompt. So how do we eliminate prompt engineering? It's not really that we eliminate it, we're reducing prompt engineering. First, like I mentioned, there are 10 different cards or 12 or whatever in the response. So when you click on one of those cards, it's essentially the same as having a second prompt. And when you see the correlated queries, actually that is related to stuff that is actually in the corpus. So if you click on that stuff, you're going to retrieve stuff in the corpus for sure, as opposed to another prompt that you're asking something that's still not in the corpus. So those related keywords leads to prompts that you can in one click, you can it's the equivalent also of doing some other prompts. So when I say there's no prompt engineering, it's organized in a different ways. You could argue that this is another prompt in the end. This is another example of how the response could look like. Like I said, is the cards format with the related prompts. Another way is by sections. That was actually the initial way I did it with Wolfram, where you have for a specific keywords that you're looking for, you get the URLs. And when I mean URLs, all the LLMs, OpenAI, they provide links, but because in long text from OpenAI, an answer like one sentence could contain information from multiple chunks. So they provide links, but they're kind of loose links. It's hard. Many times it's very hard to find. You click on the link or Perplexity or OpenAI, and it's very hard to find where is it exactly that this in that link. It's unclear to see how it's connected to the prompt. Yeah, it's loosely connected, but here it's very precisely connected to what you were looking for. So here I believe I show also categories, I show related keywords, and there's a number of parameters that essentially tells you the relevancy of each of these links, each of these keywords, and so forth. That's another version of it. And like I said, in order to turn this structured output into a standard long text. We're working on that, but so far the solution would actually involve, in this case, deep neural networks. That's probably the easiest way to do it. And you can either use a pre-trained model. The issue with the corporate corpuses is that if you're starting to work with these deep neural networks, you need highly distilled, and here I'm using the word distillation in the context of deep neural networks, highly distilled models, or you need to pre-train yourself and with a much smaller list of tokens than the standard deep neural networks you're going to find on a Hugging Face, for instance. But it's doable. Let's move to the next slide. So I was talking about different agents that you can have with our OMIN agents for synthetic data, but here's an example. If you want to solve mathematical problems, we don't do it. We would use an external tool like Wolfram Alpha. I'm not sure exactly how OpenAI does that. I'm not sure if they do ever deal with Wolfram, to use Wolfram to provide answer to mathematical question, but that would be a way to do it if you want to solve mathematical questions. Same if you want to generate SQL code or Python code. Innovative features, I'll go very quickly here. So the crawling is an important part in the sense that we are retrieving the full taxonomy, the knowledge graph embedded in these corpuses, they are high quality corpuses. And that's why you typically don't have to spend a lot of time generating a knowledge graph and stuff like that. We get the knowledge graph from the corpuses. In some cases, we need to augment because it's of poor quality, but usually we don't have to do that. So yeah, this is from Wolfram. You see all the categories, the subcategories, very detailed, very granular. And all this comes from crawling. It's just being retrieved during the crawl. This is an example of chunk coming actually, this was coming from AB InBev corporate that shows two important parts, the regular text as usual and the contextual elements. So we have kind of an infinite contextual window in the sense that it's based on the whole taxonomy attached to the corpus. And here you have tags, categories, links, titles, in addition to the standard text. So a quick word about chunking. So some original feature about our chunking is we have different type of chunks, small and large, or this hierarchical chunking, and we have a multi-index that for instance, pointing to the smaller chunks or larger chunks, the parent chunks. So with this flexibility, I think it's original. I don't know if other LLMs are doing this stuff, but that's something that would be easily implemented, that you can implement if you have deep neural networks for your LLM. So lots of these features, you can actually get them integrated into standard LLMs like OpenAI. It's not really something that only our xLLM can do. I talked about the agents. User interface, I explain how it works, as well as the relevancy scores. So here, I only have 5 minutes left, so I'll try to, like I say, I don't have the time to go through all these diagrams. I explained the architecture, but they're there in the PowerPoint presentation if you want to dig deeper into it. Evaluation is another big problem because there are tons of metrics, but they are missing a lot of things like exhaustivity or depth of the results. So that's so that's something I would like to work on and create better evaluation metrics. And in the end, it's also very much depending on the user. Some user might like content coming from OpenAI better than the stuff coming from xLLM, especially if they are laymen. Our xLLM is designed for professional users who know what they are looking for, and you don't have to provide basic information in your output. We tried some stuff for evaluation, like for instance, reconstructing the taxonomy using it and then trying to match with the actual taxonomy that is in the corpus. So that's one way to evaluate the quality. But in the end, we also have a number of parameters that the user can fine tune. So some parameters will have access to these. Some user will have access to these parameters that you can fine tune, and in the end, the parameters that these users are choosing, you can blend them together and create default parameters out of the favorite parameters chosen by the user, which is the self-tuning part of the system. An important part that I've not yet mentioned, so auto-tuning or self-tuning. And then the last part of the presentation was about different agents. I don't have much time, but one that we have put a lot of efforts in it is synthetic data generation. And so we're very good at that. We also have a very good evaluation metric for that. And there is some of the clients that we've been talking to are actually pretty much interested in the synthetic data generation, especially, banks, for instance, and in fraud detection context, to be more specific. And I think that's it for my presentation. Right now, these are talking about other agents, and I don't have the time to go through it now. So I think that's it for now. Thank you.
So how and why did you use graph tokens? Was initial, design or something you found?
We actually, we have multiple type of tokens, which is also another feature that's different from standard LLM. So graph token, in this case, they are multi-tokens that are related to the contextual elements as opposed to the regular text. So if you have a chunk in your xLLM and there is a title or there are categories attached to that chunk, and in your prompt, you have a token or multi-token combination of multiple words in our case, and those are found in a title or in a category or in a contextual element in general. We call them graph tokens or graph multi-tokens, and they get a different weight when we score the relevancy. Typically, they're going to get a higher weight because they're more meaningful. It's if the token is found in the title, it has a bigger impact than it's just found in the regular text.
Question to that question. So it's a weighted token.
Eventually, in the scoring engine, there are going to be the chunks are going to be scored, and the scoring take into account weights that are being attached to these tokens. And the same token can be found both in a title and both in the regular text or not, but the weight is going to be higher. The weight attached to that token is going to be higher if it's found in the title than if it's found in the regular text. Thank you very much. You're welcome. And there's a lot of documentation. Probably the easiest way, you look on the web, on OpenAI, on Perplexity, you do a search for LLM 2.0, and we show up at the top, so you'll find a bunch of articles relevant to. And actually, the summary of LLM 2.0 coming from perplexity.ai is very good. It's very well. We've been thinking using it for presentation to VCs and stuff like that. It's really great. So nice job from perplexity.ai. Well, if you go on a second prompt, on a third prompt, you get a lot of garbage. But at least the first prompt, LM 2.0, you get a nice presentation about what we're doing. Thank you so much. Bye, guys.